All right, today we're going to start section 2 of chapter 2, and it talks about solving one-step equations. This video will be a 2-day video. You'll have part 1 and part 2, so you'll want to revisit it for the second day of instruction. However, you could watch the whole thing and get it all, but then you'll need to revisit just to make sure that you understand. So on the board I have 4 problems, and they're all 4 equations, and they all have just one variable. So p plus 16 is equal to 47, 4x is equal to 16, w minus 12 is equal to 36, and lastly, j divided by 4 is equal to 15. When I talk about one-step equations, that means there's only one step that you need to do to get the variable to be by itself. So we're going to start at the top, and I'm going to give you p plus 16 is equal to 47. The whole idea of solving an algebraic equation is to solve for the variable. So the variable needs to be alienated and on the side all by itself. So when I look at this equation right here, what side is my variable on? It is on my left side. Therefore, I need everything else to get on the right. To get it all on the right, I cover up my variable and I say to myself, what is left? And what is left is a plus 16. When you do a solving of an equation, you do the opposite. So instead of adding 16 to both sides, I need to subtract 16 from both sides to get rid of it. My question is, why do I do it to both sides? Well, let me just share with you, I have negative 16 is equal to negative 16. That property is the reflexive property because negative 16 is equal to negative 16, and when I combine that with the one above it, it does not change the value of the equation. So p from nothing is p. Positive 16 minus 16, those cancel each other out. And then I have an equal sign, and then 47 minus 16 gives me 31. So how do I make sure that I have it correct? Plug it back in. So I have p plus 16, and I found p to be 31. So 31 plus 16, that gives me 47. And the question is that equal to the other side of the equation? So is 47 equal to 47? Boom, boom, check, check. So my solution is p is equal to 31. That's this equation right here. Do this one, and that would be w minus 12 is equal to 36. So I have to find my variable. Here is my variable, and I want everything else to be on the other side. So what do I have to get rid of? Well, if I cover up this side, and I cover up my variable, I got to get rid of that negative 12. And to get rid of it, I have to do the opposite. That's a property from last chapter. So therefore, I'm going to add 12, and what I do to the left, I got to do to the right. I have no choice. So then I have equality, and I bring down my w. My 12s cancel each other out because there's that additive inverse. It says a number and its opposite will give me 0. And then I have equals 2, and then 36 plus 12 is 48. How do I make sure I'm correct? Plug it back in. 48 minus 12. The question is that equal to 36? So 48 minus 12, that would give me 36. So is 36 equal to 36? Boom, boom, check, check. My answer is w equals 48. All right, let's do another problem. And let's do 16 is equal to p plus 12. All right, what side is my variable on? Oh, this time my variable is on the right side. So if I cover up my p, and I cover up the other side of the equal sign, what do I have to get rid of? I have to get rid of positive 12. And how do I get rid of positive 12? I add it with its opposite, and the opposite would be negative 12. So what I do to the one side, I do to the other. That's that reflexive property. So I have 12 minus, how about 16 minus 12 is 4, is equal to, bring down my p, and positive 12 minus 12, those cancel out. Again, check it to make sure, and I have 16, is that equal to 4 plus 12? 16 is equal to 12, so boom, boom, check, check. My solution is p is equal to 4. So it doesn't matter which side the variable is on, it just has to be there by itself. So on the first two examples that we did, let's talk about the properties that we used. We used the property of the additive inverse, because that was a number plus its opposite will give me 0. We also used reflexive, and reflexive is that reflection in the mirror where 4 is equal to 4. So those are the two properties we've used so far. Even on the one where we had p plus 16 is equal to 36, that's not the same problem, but it's the same situation. To get rid of my 16, I had to subtract 16 from both sides. So that would be this property right here. Or if I would have had p minus 6 is equal to 30, to get rid of my 6, I had to do positive 6. And that also is the same additive inverse property. Now, where is the reflexive coming in? That's because negative 16 is equal to negative 16. I did not change the value. And positive 6 is equal to positive 6. I did not change the value. And then I combine both lines and I solve. So p would be equal to 20 and p would be equal to 36. How do I know? Plug it back in, boom, boom, check, check. Okay, part 2. Okay, we did addition and we did subtraction. So now we're going to do multiplication and division, and that's why I call it part 2. The problem right up here says 4w is equal to 16. When you have 4 and w right next to each other, that means it is a product. So I have to get the variable by itself, which means I need the coefficient to be 1. How am I going to get the coefficient to be 1? I do the opposite. Therefore, I divide both sides, because right now it's being multiplied. So I divide both sides by what is being multiplied. What is being multiplied? Well, what is the coefficient of w? That is what's being multiplied. So I do the opposite, which is division. And therefore, 4w and 4, they cancel out, and it leaves me just w. And then 16 divided by 4 is 4. Just like on part 1, I plug that back in, and I say to myself, 4 times 4, is that equal to 16? Boom, boom, check, check. My answer is 4. Now this is where it gets a little tricky, because which property is that? Let me show you what I'm talking about. Okay, I'm going to rewrite this equation, 4w is equal to 16, and I'm going to show you how I'm really using the property. I want this to be 1. So what do I have to multiply by? What do I have to multiply 4 by to get that to be 1? It has to be the reciprocal. Oh, so what property is it that says 4 times its reciprocal is equal to 1? What property is that? That is the multiplicative inverse. So therefore, I really multiplied through by 1/4. Well, it looks different, but it's exactly the same that I did over here. It's just a different view of it. These cancel out. 1 times W is W. 4 goes into 4 once, 4 goes into 16 4 times, and 4 times 1 is 4. I get the same, it's just using the property in a exact instead of a creative way. So we did use multiplicative inverse. All right, so part 1 we did an addition, had to solve by subtraction. Part 1 we did a subtraction and had to solve by addition. Part 2 we did a multiplication and had to solve by division. So part 2, if I give you a division problem, I have to solve it. So let's do it. J divided by 6 is equal to 5. I need my J to be by itself. So to get J by itself, right now I have it division, or I have it as 1/6. So to get rid of it, I do the opposite, and the opposite is multiply. And what am I going to multiply both sides by? I'm going to multiply by the reciprocal of this. So that would just be 6. Okay, stop, because you're saying the reciprocal. Yes, watch. J over 6 is really 1/6 J, isn't it? So what is the reciprocal of that? Well, the reciprocal is turning it upside down on its head. So the reciprocal of 1/6 is 6 over 1, which can simplify to 6. All right, let's go back to the problem. So I'm going to multiply both sides by 6. Those cancel out, and it leaves me J. And 5 times 6 is 30. I know by now you're tired of hearing it, but let's check. If I put 30 divided by 6, is that equal to 5? Well, let's check. 30 divided by 6 is 5, and 5 is equal to 5. So boom, boom, check, check. J is equal to 30. That's why we did chapter 1. You have to know the properties, because if not, all you're going to be doing is saying, well, that's the opposite, that's the opposite. But mathematically, we're using properties to isolate the variable. Remember, revisit me twice. Part 1 the first time, and part 2 the second time. I'll see you in class. Take care. Bye.